Hello folks, so this is going to be a pretty quick video for you just on the connection between hypothesis tests and confidence intervals, as well as how we need to use tests wisely, right, when we're running hypothesis tests out in the field, as it were. I've talked about these things in kind of sprinkled throughout a lot of the videos that we've talked about and that I've made for you on Inference, but I want to explicitly make sure I tell you all of these things here. So especially for means, the connection between tests and intervals is really, really strong, even stronger than those same things for proportions. And that happens mostly because both intervals and tests use the standard error of the sample means. If you remember with proportions, confidence intervals have to use that sample proportion when calculating their standard error, but the hypothesis test, we use the pooled proportion, right? So it's a little bit different, right? But for means, we're using the same thing each time, right? Remember, we're using, no matter what, we end up doing this, xx divided by the square root of n in both confidence intervals and tests, okay? So, the main connection between hypothesis tests and confidence intervals lies in the confidence level and the significance level that we set, okay? So a two-sided test, so meaning an alternative hypothesis with a not equal to sign in it, okay? So a two-sided test at a certain significance level, say 0.05, and then a 95% confidence interval, give very similar information about the population parameter, okay? So in tests and intervals that go together in those corresponding intervals and tests, the alpha value is usually 100% minus the confidence level, right? You're going to get similar information from those two things, okay? So another connection that's important here is that when a test rejects the null hypothesis, the corresponding interval won't contain the claimed value, okay? Which I hope like intuitively kind of makes sense, right? If our assumption is not true, right, then the interval would be really far off from that true value, right? The corresponding interval shouldn't contain that claimed value, okay? And then it goes the other way as well, right? So if a test fails to reject the null, then the interval that corresponds with it likely will contain that claimed value, okay? Now, a couple other quick things about using tests wisely. So let me clear this off, and I'm actually going to make this, the actual notes page a little larger on your screen here. Okay, but there's a couple of things that we want to note and keep track of, okay? First, when you as a statistician are designing a test, right, and you're thinking about a couple of different things, right, that you have control over, right? One of those things is how large of a sample you need, okay? So if you're going to set a very small significance level, so a small alpha value, that requires much stronger evidence to reject the null, okay? And you typically will get stronger evidence if you have a larger sample size, right? And mathematically, that goes back to how we calculate the test statistic, right? Because you're always dividing by the standard error, right? So if you have a larger sample size, you're going to have a smaller number in that denominator, right? So you get a larger test statistic and thus stronger evidence against your null, okay? And you can also achieve that by setting a higher power level, right? Which, remember, is directly related to the significance level that you set, right? So a higher power of a test does give us a better chance of detecting a difference when it actually exists, right? So at any significance level that you choose and any power level that you want to have, right, if you want to detect very small differences between the null and alternative values, you have to have a larger sample size, right? So these very small differences require a larger sample size, okay? Right? Another thing that kind of goes into that is this idea of statistical significance versus practical importance, which we have talked about a little bit. And I had you guys explore in some of the discussion questions in the last unit. Okay. So if we have a null hypothesis that we can reject at typical levels, which is like the standard alpha levels that I have you select, right? 0.05, some people choose 0.01, right? So the common ones, right? Then that means if we can reject at a pretty standard level, then that's pretty good evidence towards a difference. But that difference might be very small, right? So that goes back to is the rejecting of the null hypothesis, or is that difference practically important, right? Like, does it have a practical impact in the real world, right? And in the context of that problem, okay? So when you have large samples, even small deviations from the null hypothesis will end up being significant, okay? And then another thing that you want to make sure that you're aware of is something called multiple analyses. Okay, so when you reject a null and you get a p-value that is statistically significant, right? What that's supposed to mean is that you found this difference that you were looking for. Okay, but this really only works, right, if you follow the process that you're supposed to follow and don't try to attack a problem from using multiple analyses at the same time, right? So the reasoning behind statistical significance will only work, and it will work well if you follow the hypothesis test process, right? The scientists have to decide what difference they're looking for, right? Which is why you write your hypotheses the way that you do. You design a study well to search for that difference, right? And then use a test to weigh, right, the evidence that you get, right? Essentially what I'm saying is that the statistical significance that you get from a particular test is really only valid for that scenario and that test, right? If you try to transfer it to other scenarios, other settings, other populations, other samples even, the significance level and the decision that you make may not necessarily have any meaning, right? So there's that, right? So this is more about like the ethics of statistics, and it doesn't come up a lot on the AP test, and a lot of it is like common sense, okay? But the key things to remember from this little video are that that there is a pretty strong connection between say a test at an alpha level of 0.05 and a 95% confidence interval. They're going to tell you similar things. The larger the sample size, the more likely you are to detect these really maybe small differences between your assumed value and your sample value, right? And the other important thing to remember here is that when the decisions that you make with a test really only apply to that sample or that scenario, and you have to be careful if you're going to take it and extrapolate it further and make sure that you have a significant enough piece of evidence to back that up. All right, so that is it for this video, and I'll see you in the next one on paired t-tests. Bye, everybody.